Hello again. Welcome to SOS, also known as Session of the Sessions. Today we will talk about solid. What is solid? Solid is very important group of software design principles for almost all software engineers. Again, what is it? Solid is only guideline group we should use. The goal of these principles is to make code changes as side effects free as possible. The solid has 5 principles. The 5 principles are single responsibility, open closed, Liskov substitution, interface segregation, dependency, inversion. Today we will demonstrate common violation of solid principles in Ruby, the programming language we work closely during our sessions. History of solid. Robert C. Martin, the co-author of Agile Manifesto, introduced his set of solid principles for object-oriented design way back in 1985. These practical recommendations help developers design flexible solutions, detect code smells, and refactor their code to prevent the issues. By following solid design principles, developers can achieve maintainable and extendable code base. We will talk a bit about practical use of solid principles rather than focus on theory. The first principle is the single responsibility principle, SRB. SRB means a class should have a single responsibility. In other words, any complicated classes should be divided into smaller classes than are that are each responsible for a practical behavior, making it easier to understand and maintaining your code base. Every class should have a single responsibility, and that responsibility should be entirely encapsulated. All its services should be aligned with that responsibility so far. While the concept behind this principle is quite clear, however, developers admit that putting this principle into practice requires some skills. Why? Since a class's responsibility is not always immediately clear. Martin considers responsibility as a reason to change and conclude that a class and module should have the only reason to be changed. Combining two entities that change for different reasons at different times is bad design. And also leaving each class with a single responsibility makes classes maintainable. The goal of SRB is to fight complexity that creep in while you are developing an application in application logic. There is an example of code with bad smell. This one. as we see here. The class user shown here handles two tasks: find user in the method find and logging in method log. The class looks quite simple as written. However, extending this class in future may be a problem, since we will likely have to change the logic of the class. The SRP principle tells us that a class should implemented one single task. Each class should implement one single task. And therefore, according to this principle, we should divide the user class into two classes. After refactoring that code, let me show you the new code. We created two classes. Each class performs a specific task. The user class finds user, the logger class logs the errors. If we wanted to expand the class responsibilities for finding, for example, in the future, we could simply make necessary changes without having touched the logger class. Clear? That was all about single responsibility principle, SRB. The second principle, open-closed principle, OCB. OCB means modules, classes, methods, and other application entities should be open for extension but closed for modification. Simply, all modules, classes, methods, etc. should be designed in modular way so that you are able to change the behavior of the system without changing the code base. The principle is important to follow because the code base of software project is often modified throughout their lifetime. For example, to meet new customer requirements, we expected a lot of changes. Therefore, a developer's goal should be to build a flexible system that is easy to modify and extend. And the OCP helps developers to achieve a flexible system architecture. This code demonstrates a violation of OCP. In this code, the logger class formats and sends the log, but OCP wasn't followed here. Since we will have to modify the logger every time we need to add additional senders or formatters. This means that it's preferable to come out from the class that you want to use than modifying it directly. So we have the class logger and it format and sends. We have a method format and method delivery. After refactoring the code, we will be able to do extend. In this example, we have segregated senders and formatters to separate classes and enabled adding new senders and formatters without having to modify the base code. This is the logger class, okay, and this is the sender. We have a class for each sender, and we have a class for each format, data formatter or row formatter. So in future, if we wanted to add new formatter, we just add a new class without changing in the base code, without changing the logic we have in the logger class. OCP software entities should be open for extension but closed for modification, such as an entity can allow its behavior to be extended without modifying its source code. That was open closed principle. Then the third principle we have today is Liskov substitution principle, LSP. LSP was defined by Barbara Liskov. Barbara Liskov is an American computer scientist who was an institute professor. She was one of the first women to be granted a doctorate in computer science in the United States. Barbara Liskov defines the LSP as, let's say, if S is a subtype of T, then objects of type T may be replaced with objects of type S without altering any of desirable properties of that program. Also, this is how Martin defines the principle by saying subclasses should add to base classes behavior, not to replace it. The principle states that parent instance should be replaceable with one of their child instances without creating any unexpected or incorrect behavior. Therefore, Liskov substitution principle ensures that abstractions are correct and helps developers achieve more reusable code and better organize class hierarchies. We have here a piece of code that violates LSP. In this example, we are implementing two classes: a base class, which is user class, and its child class, which is admin class. The child class violates the LSP since it completely redefines the base class by returning a string with filtered data, whereas the base class returns an array of books, which is violates the LSP. In base class, we have books method. It returns list of books, and in the child class, we have the same method, but it returns different type of data. It returns books as string. Many developers find LSP tangled and complicated. Actually, this principle is based on the fact that a derived class must be substitutable by its base class. Now let's see how we refactor we do refactoring for the code. Now, to comply with LSP, we can segregate the filtration logic and the books string generation logic into two methods, books and books string. Therefore, we refactored the method books that filters user books. So the method returns the same type of data as the base class. I see actually it's a simple one. Now, with the fourth principle, interface segregation principle, ISP. ISP can be described as clients shouldn't be depend on methods they don't use. Several client-specific interfaces are better than one generalized interface. ISP splits interfaces which are very large into smaller and more specific ones, so that clients will only have to know about the methods that are of interest of them. ISP is indeed to keep a system decoupled and thus easier to refactor. Maybe we can do change and redeploy. The idea is main classes should be segregated into smaller specific classes, so their clients use only methods they need. As a result, we get the interface segregated according to their purpose. So we avoid fat classes and code that's hard to maintain. ISP is best demonstrated with a piece of code. This is how looks the code that is crammed with generic functionality. In this example, we have a piece of code that represents a machine interface. As we can see, the interface is used by two types of users, a user and technician. Each user, or each type of user uses only few interface abilities. However, for example, the class user uses only the method turn on and type. ISP tells that one class should contain only the method it uses. To make that example comply with the ISP, we created two interfaces, a separate user interface and a separate technician interface. In the machine class, user will be able to turn on or to know the type of the machine. A technician using a machine maintenance class will be able to do maintenance for the machine. With this design, we segregated the logic into two interfaces. we have avoided unused method and now have two smaller interfaces with methods that perform specific tasks. Now we finish with ISP. The fifth principle and the last one, dependency inversion principle, DIP. DIP refers to a specific form of decoupling modules. Its definition, the definition of DIP has two parts. First, high-level modules shouldn't depend on low-level modules. The second, both modules should depend on abstraction. In addition, abstractions shouldn't depend on details. Details depend on abstractions. Martin doesn't consider the DIP to be completely separate principle, but he claims that the DIP is the simple result of strictly following two other principles, Liskov substitution and open-closed principle. According to Martin Point, code that follows the LSP and OCP principle should be readable and contain clearly separated abstraction. It should also be extendable, and child classes should be easily replaceable by other interfaces of the base classes without breaking the system. In this code, we implemented the logic for a printer. The printer class has the method print, which performs data output. The class printer depends on class PDF formatter and HTML formatter instead of abstractions, which indicates the violation of DIP principle. Since the class PDF format and HTML format may contain the logic that refers to other classes, thus we may impact all the related classes when modifying the class printer. After refactoring, let's see how we conform to DIP. The implementation of low-level details is done in separate classes, PDF formatter and HTML formatter. Now, this code, the printer, which is the high-level object, doesn't depend directly on the implementation of low-level objects, which is PDF and HTML formatters. In addition, all modules depend on abstraction. Now, our high-level functionality is separated from all low-level details. So we are able to easily change the low-level logic without system-wide impacts. And that was DIP. Conclusion. In our conclusion, remember that solid principles themselves don't guarantee great object-oriented design. To apply solid principles smartly, you need to know exactly what problem you are trying to solve. Simply checking off boxes and saying, now my code conforms to solid design principle is the wrong approach actually. However, if applied correctly, so solid design recommendations can help you build system architectures that easy to modify and extend over time, which is exactly what every developer should strive for. That's all. Thank you for watching. Please leave your comment if you have any question or any suggestion. See you again in next session of sessions. See you.